Welcome, everyone. Thank you for sharing some of your time with us. We know that at the end of the day, time is everyone's most valuable commodity. So we appreciate you making time for this great event. We're also very thankful to our great partner in Microsol for putting this event together and, to Harry's point, wanting to communicate the best, latest, greatest, and proven solutions for you out there in the marketplace. So I'm going to give a few slides here as an introduction to our presentation of the fabrication solutions that will be given by my colleague William Spier from Autodesk. And just a quick title here for some thoughts, I'm calling this the subcontractor's dollar, extending design intent, because I think that's really a primary theme that we can start with when we're thinking about the fabrication products. So the next slide there, you'll see just trying to give you some perspective on who I am in terms of how I formed my opinions, right? Because we all hop onto these WebExes, and oftentimes we're just seeing slides and maybe not knowing or entirely sure how the person giving them has informed their own opinion. So just quickly on me, I spent some time in practice. Amongst others, I worked for Foster & Partners in their London office. And if I had to summarize that job, it was all about turning crazy shapes into flat 2D lines. Some of you may know Foster & Partners International Practice, lots of highly geometrically complex projects, and it was all about trying to figure out how to take that curved geometry, how to fit stuff inside of it, and how to make it flat so that we could measure and price it for the trades. I spent some time in the channel, a number of years in the channel, working as a director of BIM implementation, really what I call the early days of BIM, BIM 1.0. As most people were making that heavy lifting transition from 2D to 3D. And so I got to see what was happening with architects, structural engineers, mechanical engineers, owners, contractors, developers, subcontractors, etc. I spent quite a few years thereafter with a company called Navigant Consulting. I did two things there. One was as an owner's rep, primarily focused on new construction and BIM to FM transitions for hospitals. And so I saw firsthand nationally with that practice a lot of the best practices that hospitals were using to make the most of the great work that the design and construction teams were doing with BIM. And then the other half of my time there was spent in the world of construction claims and litigation. So I saw a lot of projects that didn't go well and how they were ultimately mediated or arbitrated or litigated out, and the toll that took on everybody involved. And interestingly enough there, just a side note, I was actually a retained BIM expert on a couple of mediations and arbitrations that involved BIM. And interestingly, I think even more so, was the fact that the arguments weren't about BIM's ability to prove value. They were actually used as tools to put a microscope on the failure of others who hadn't. So that gave me another perspective on the industry. And then most recently, here I am with Autodesk as a territory manager in the Northeast. So I'm again have the privilege of being exposed to everything that our customers are doing. So quickly then on the next slide, I'm just going to talk through what I think are again, good themes to start with before I turn it over to the meat of the presentation and the real interest by William. So as most of you on the call may know, if you've already worked with BIM tools, I mean, we've traditionally had a fairly decent BIM workflow, but it's been very focused on designing and coordinating, right? We spend a lot of time and energy on intent. We move to spatially coordinate that intent, and we have processes in place to do that. But then detailing and fabricating becomes, in some ways, a distinct endeavor. And if we move on to the next slide, what I think we'll see is how the marketplace and then ultimately the academics and then also BIM mandates are proving this out. So you can read any number of market studies you want. We just had one up there on the screen from McGraw-Hill, their latest business value of BIM for construction and major global projects. And they're recognizing, I think, as we've probably most of us have known in the industry, that a trade contractor's BIM proficiency directly impacts project success. BIM money meets the road with the MEP contractors. And as you can see there's many statistics in these McGraw-Hill reports, but this one I've chosen in particular, speaking about MEP contractors, you can see right there behind the steel at roughly 52% in agreement that those trade contractor skills are high and need to be high for project success. And then it's not just the marketplace, because we always look at some of these marketplace reports with a little skew, right? Because we have to be discerning. So if we then look at what the academics are doing, I find it interesting on the next slide here. You know, hard research in refereed journals has proven out BIM value propositions. You know, I've chosen one example here of a refereed journal. If you go to the ASCE library and you just did a BIM search, over there on the right-hand side, you'll see publication year, and then in brackets the number of publications where the research was either directly focused on building information modeling or BDC, or either of those terms just appeared in the title. And overwhelmingly, the majority of those pieces of research are showing us pro-BIM determinations. And those numbers are pretty dramatic. If you look at the 2008 library count of 18 versus where we are this year, 287, obviously something real is happening, and referee journals are taking note. It's not just marketing. And then lastly here on this next slide, I think if we move from the academics into the mandates, we're finding, and most of you are probably experiencing, that BIM is a must, right? So ownership at any level is realizing that those MEP contractors are where the BIM money meets the road. And some of them are making it explicit or partially explicit in their own mandates. So here I've just cut and pasted part 2 of a 2-part requirement for the state of Ohio's Building Information Modeling Protocol. And you'll see there that one of the thresholds for whether or not the state of Ohio decides to use BIM on publicly funded taxpayer projects is whether or not that project has 40% of its overall construction value dedicated specifically to plumbing, fire protection, and the other MEP trades. So, you know, across the board, whether it's the marketplace, the academics, or the mandates, you know, it's reinforcing that idea that, you know, BIM money meets the road with the MEP contractors. So if we go back to kind of where we started here on this last slide, and I'm going to quickly then turn it over to William, you know, what we want to do is we want to move from that 3-step process, which is not entirely unintegrated, we're not suggesting that, but we want to get to more of a information flow with intent, coordinate, and detail, fabricate, kind of being understood as not necessarily one process, but one continuum. And we're very excited here at Autodesk about the changes and the aggressive new products that we have to answer this question. So that's enough from me on kind of some high-level thoughts, maybe to prep us up. I'm going to turn it over to William, who's really going to show you the meat and potatoes here, and I think impress and blow a lot of you away. William's a fantastic guy as a person, but he's also highly, highly skilled in this world, and he has a lot of domain experience. So you're in for a good show. William, we can see your screen, but you might be muted.
Thank you. All right, so thanks, Jay. This is William Spier. I am an MEP in Design to Fab SME, subject matter expert for Autodesk. I've been in the industry for a little over 20 years now. Started off with a consulting engineering firm in Seattle, Washington. Ended up moving from that to working for the owner side of things for Merck Pharmaceuticals, doing O&M work for them through Johnson Controls, and then eventually wound up working for Midwest Mechanical Contractors in Kansas City, where I live now. So the point of all that is more or less started off on the design side, went to the owner's side, and eventually wound up on the fabrication side, where I really learned what actually happens to all the files and so forth that we send out to the industry. You know, and I learned that there's good firms and bad, and good designs and bad and whatnot, but that at the end of the day, when it's time to build a building, the subcontractors are the ones who eventually have to make sure it all works and get it done right and get it delivered on time and so on. And so that's a little bit of my background. That's where I've kind of seen all angles of the industry, if you want to put it that way. So we're going to take a look at Fabrication CADmep, ESTmep, and CAMduct. They are the hero products for mechanical, electrical, and plumbing engineering fabrication. Some of the business challenges, more frequently, subcontractors are being asked for BIM deliverables, fabrication level BIM models, so we're going to look into a little bit of that. Everybody wants to maintain a competitive advantage. How do you do that? You can see that's through prefabrication and modularization. There's pressure for leaner processes to deliver quicker for less money. And now, being that you have to work with different entities in many different ways based on what kind of business you do, you have to have technical flexibility as well to collaborate with all of them. So we're going to go through all of that and take a look at that. From Autodesk's standpoint, early on, or 7 years ago when I came to the company, we were really strong over here in concept and design, right? But where we were lacking was detail and fabricate. We really didn't have much there. And install, how do you get it all installed? So when jobs left MEP firms and it went out time for detailing and fabricating and so forth, it wasn't in Autodesk software. And so I've asked a couple of times, and finally somebody paid attention, and we wound up acquiring micro application packages, and that is the best package that I'm aware of. And primarily it's because between Fabrication CADmep, which is the design and detailing tool, Fabrication ESTmep, which is the estimating tool, and Fabrication CAMduct, which drives your plasma cutters and coil lines and so forth, they're the only three products in the industry that I'm aware of that share a common database, meaning there's no hassle trying to figure out how to get the information from one product to another. And so those three products combined take care of the detailing, fabrication, and install side of things. And there's a couple extra products like Tracker and Remote Entry that come with CAMduct that help particularly on the install side. And in general, when you look at things, you can see over here on the left side that, you know, our products, again, we're really strong on the programming side, conceptual design, detailed design, analysis, and even documentation. Of course, documentation, that's where AutoCAD was the strongest and so on. But then once we're finished with our CD documents and it goes out to bid, this section in here is where we didn't have anything. So we're going to be looking at these products in here today for fabrication and construction. And then some of the other tools that we offer now, like BIM 360 Field and Glue, also help with a lot of this over here in construction logistics and so on. And the products, again, do the detailing and estimating, right? So CADmep does that, ESTmep does that, the fabrication, CAMduct, some of the stuff you can spool out of AutoCAD or CADmep, Fabrication CADmep as well for fabrication, and then the installation side. So these are where these three bureau products play. So what we're really doing ultimately at Autodesk is we're looking at the industry's trend towards building information modeling, as Jay was talking about. And what we want to do is we want to extend that into the subcontractors. Now, the subcontractors for years have actually been doing building information modeling because they actually are laying out this geometry in 3D and making sure it all is coordinated and so forth, right? What we want to be able to do is bridge the gap from the designs and fix the break in the design cycle where more or less once the design leaves the office and heads out for bid, the subcontractors, like at my office when I first started, we poured over a roll of drawings and said, that looks nice, and after 30 minutes or so, they rolled it out and threw in a corner, and one of the guys said, all right, let's start over again, which was a shock to me. I didn't understand why. And it's because we can't leverage the designs that are being given to us for a number of different reasons. Primarily because no matter how hard we try on the design side, they're still conceptual in nature once they get out to bid. So that's what we're trying to do, is extend that building information model work and bring it over. And we're going to look at how to do exactly that today. I'm going to show you how the software does that. Again, it's still based on the fact that you get a decent design. If you're getting a crummy design, you just can't fix that, right? There's certain things you can and can't do, but I'll show you how to do both. So more or less, we're trying to support BIM workflows all the way through, and being that everybody's switching to building information modeling, and rightly so, because it really is a powerful way of building buildings, and if it's done right, we'll save everybody a lot of time and money. We're going to help you prepare for the future, add value through what you're doing with fabrication and interoperability, and really just help you support on those BIM, or deliver on those BIM mandates. So the three software packages include CADmep, which is going to do your design and detailing for you, and ESTmep, which does the estimating. We're going to convert a Revit model today. I'll show you how that's done and what that looks like. The ITM content is either class specific, like pressure class for your ductwork, or manufacturer specific. And if you're interested in seeing more of it, you want to see what's actually out of the box, we also have that content mirrored on building3dcontent.com, which is an Autodesk website where you can download entire services for free. There's even a place for you to make requests. In other words, if there's a brand or service that you need, you can actually put that out on the idea station. But at the end of the day, it really helps you accurately cost models and gives you really minute control over costing and everything you need to really make sure that what you're putting out you can trust it's going to work. So to actually fabricate it, you can spool from CAD and MEP. You can send out CAMduct runs to CAMduct where we will actually nest the panels for you. You can nest them on the cloud for particularly large jobs. It makes it very quick. You can export the BIM data anytime you want to for procurement, accounting, and other business scenarios. So it's pretty straightforward stuff. And then for installation, like I said, when you get CAMduct, there's a couple extra products that come with it. Tracker is one, and remote entry is another. So Tracker actually lets you put barcodes and QR codes on all the panels and track them at any stages you want to create, from burn to in the bin for being built, or the fittings completed, wrapped on the truck, out the door, and received on site, installed. And at each stage you create, whatever stages those are, the model will actually change color so you can see how that is progressing, whatever it is, school, stuff, work, you name it. And if you need missing piece or something got broken, let's say that never got scanned in, then you can use remote entry to recreate or create a new piece if you need a custom fitting right from the field, and it'll go straight to the plasma cutter. So there's some nice tools in there that will help you really round out your workflow. The trends in the industry right now is about 50% of the AEC industry is using it here in the U.S. and 36% in Europe. And a lot of contractors believe it's going to hold even more importance in the next few years. But most important, really one of the big takeaways from today's presentation should be that building information modeling really allows a greater degree of trust in a virtual model. And that trust is then a catalyst for being able to prefab and do modular prefabrication, right? No more boat anchors, no more building something and finding it didn't work in the field. So prefabrication ultimately is the key component that drives improvements in the construction industry and in productivity. And we're going to see, actually, I'm going to show you the video here at the end. I'm going to show you a brief video where that statement is made directly by Breck Smiley up here. He says, one factor today that differentiates your business from your competitors is the percentage of work you prefabricate. So really what do you need to do more prefabrication? You need more time, and you need it earlier so that you can prefabricate, and you need to trust coordination enough to do it, right? So time and trust in the design, and that's what CADmep, ESTmep, and CAMduct really does for you with that common database. And Miami Valley Hospital project was a great example. I'll show you just a couple of quick slides on that. This is where they actually decided they were going to modularize the pre-construction or prefabrication on this. They had 178 patient rooms, 129 MEP racks, so they were doing rack piping as well and ductwork. And they completed all that across 5 spec stations. The total number of workers in the shop was 18. And if you look at that shop, you notice it's never raining, it's never too hot, it's never too cold, they're never shoveling snow. All the tools are right there at the table. They're never waiting for a crane lift to bring up a box of bolts so that they can finish some last piece of work they're working on. It's an incredibly work-conducive environment. The prevailing wage for site labor is $50 an hour, but for shop labor it's about $40. So it's about a 20% savings. On a conventional job site, a plumber's installation quota is 200 feet of pipe per day. On Miami Valley Hospital, they were installing 600 feet of pipe per day. What's the productivity increase? 3 times, right? And this is data that was from McGraw-Hill, taken from McGraw-Hill, who did a study on that particular project. Not to mention there's worker safety as well. How many times do you go up and down the ladder on a job site? Right? The rack crews were able to do all their work standing on the floor. So the number of injuries in the shop was 0. So there you can see where you're looking down from the top. You know, you don't have to worry about access any longer and so forth. So even the insurance companies like prefabrication. Where the 3 products fall in the workflows, you have Fabrication ESTmep that covers all of it, from the detailing to the fabricating to the installation, because it covers not just the material costs, but it also covers the labor costs. We'll show fabrication labor as well as installation labor. And by the way, the ITM content that's common to all 3 of these products has placeholders in it for catalogs. So if you have a catalog subscription to Ferguson or PHCC or SMACNA or whatever it may be, and it comes now, by the way, our content comes now with Harrison pricing already associated to it. So when you go to that Building 3D Content website, you'll find it there. You can actually tie into those catalogs as well. So as soon as I lay out a service of copper piping for heating water supply and return, I immediately have not only the geometry correct, with weld gaps correct, or engagement lengths correct, and so forth. But I also have all that costing associated to it as well immediately. And if anything changes, an estimator changes it, then immediately that pricing will change. And if they change to a different material, so will the geometry. So it's all common database, and it all makes very easy to change things out. CADmep, obviously, if you're a design build firm, you can start over there on the design side. If you're plan and spec and you receive the files, you can take them to CADmep and detail them and fabricate them. Fabrication CADmep, which was the Revit converter, has now been rolled into CADmep. So there it is there. And then you have Autodesk Fabrication CAMduct, which sits over here in the fabrication zone. And then down here at the bottom, I don't know if you can see this or not. I just wanted to make sure you can see it a little more clearly. What does that say down there? Shared Content Database. That's one of the key takeaways from this is remember that what we're talking about is 3 separate products. Fabrication, CADmep for the detailing, ESTmep for your estimating, and CAMduct for driving your plasma cutters. All 3 share a common database. Right? That way there's no worrying about trying to get information from one group to another. In some cases, I've been to firms where they don't even share the information. They just tell them, here's the price that you need to be close to. Right? Well, those days are gone. So what are the 2 workflows basically? It depends on what your business type is. If you're a design build firm, you have engineers on staff who provide designs to detailers and estimators, and then they send that to the shop for fabrication. So the workflow there is the most flexible. You can start designing a fabrication level detail directly in CAD and estimating, or MEP, you can design an EST as well. Or you can start in AutoCAD MEP or Revit MEP if you're a design build firm and convert that when you desire. If you're a plan and spec shop, you have detailers and estimators on staff that receive designs from outside firms, and then you detail and estimate those and then send them to the shop floor for fabrication. And in those cases, what you use depends on what you're receiving. So if you're getting a 2D receivable like PDF, your AutoCAD background and so forth, then you can draw over those with CAD or ESTmep. If you have a 3D receivable like Revit MEP or AutoCAD MEP that was done in 3D, you can take those files literally and grab the entities from those files and map those over to CADmep or ESTmep's map. And I'm going to actually run through that second scenario today because everybody knows what drawing over looks like, so we'll do something a little more exciting. And then obviously the third company is both design, build, and plan and spec. Some of them do both, and then obviously workflows 1 and 2 apply to both. All right, so with that, what I'm going to do at this point is jump in and actually drive for a minute and show you what some of this looks like. So what you're looking at right now on screen, you should be able to see a Revit file. This is an actual live Revit model that we're looking at here. And when you have Revit installed on your computer, and let me maximize this so you can see a little better. When you have Revit installed on your computer, once you install CADmep or ESTmep, what you're going to find is you get some additional tools up here in add-ins. So you'll see you have what's called an RME to Fab, that's Revit MEP to Fabrication palette up there. And a couple of tools that we're going to look at today are Store Design Line Elements and Store Graphic Elements. And really what these 2 are, these are the elements that you're going to store that actually you're going to fabricate. So you're going to fabricate ductwork and piping typically, and conduit or cable tray and conduit and that sort of stuff. And then the graphic elements are the elements that are actually the equipment that you're serving between. You need to bring over reference points. So the VAVs, the diffusers, the pumps, the sinks, and all the different things that are being served. So the way to do it is very straightforward. You simply grab everything, and Revit allows you to filter through them. So we'll just turn everything off and pick what we want. So in this case, I'm going to bring over my air terminals, bring over my flex ducts, mechanical equipment, and pipe accessories. So in this case, I'm picking the 4 things that make up all the equipment. So filter those out. And when I do, simply go up to my add-ins and store graphic elements. All right, so those are stored. We'll do one more window and grab everything again, repeat the process. And this time we're going to pick up all the design line elements. So we'll pick up cable tray fittings, and cable trays, duct fittings and ducts, pipe fittings and pipes, and then go back and store those as our design line elements. And you can see as soon as I hit that, then these are grayed out here, displayed design selection and clear design selection are now highlighted, so if I made any mistakes, I can go and fix those, right? But that's more or less it. So in Revit, I'm just picking those entities. Remember I talked about a 3D to 3D workflow. So if you're a plan and spec firm and you're getting Revit files, this is what you'd be doing. You'd be receiving these files. Obviously in Revit too, you can go and fix anything here if you see blatant errors or mistakes or something that needs to be changed or routing, what have you. Being that Revit stands for Revise Instantly, it lives up to its name. So you can grab things and fix them in Revit and then do the grab that we just did where you're grabbing all these elements, right? So let's take that and send that out. And we'll call this one Microsol, so we can remember it for today. Save. And there's the heavy lifting to get this out. And remember, too, that if you get a Revit file that's not done well, there's problems with it because that is the real world. You're not going to get perfect files all the time. You can also use the software to export this out. So I can go up here and export this literally out as a 2D CAD background and then bring that CAD background into CADmep or ESTmep and draw over it. Right? We're used to that workflow. It's a pretty straightforward workflow. But that's it. I'm pretty much done in Revit at this point. So I'm going to leave Revit and head on into CADmep. All right, so once we're in CADmep now, we're done with Revit, we can shut Revit down. We've got that RIF file exported out. What I'm going to do here is bring it into CADmep. So process run is the command to bring it in, and you literally just go find the file you just created from Revit. And we're looking for Microsol RIF that we just created today. So we'll bring that one in. When I do, you can see up here that I've got mapping dialog box, right? And what it's doing is it's showing me all the different services that are created. And where do these services come from? These services come from Revit. So it's looking at Revit, at the systems named in Revit. There's return air, return hydronics, supply air. What else do we create? Supply hydronics and so on, right? So, and it has the different pressure classes on here, the water gauge, what the service was named, and so forth. So all this information comes over. If you get a Revit file that's not so good, you'll see three things in here: pipe, duct, and electrical. That's it. So it depends on how discrete whoever was doing the Revit file was with discretizing their systems. Again, if it's not a very discrete file, in other words, it's all piled into one system, you can always draw over those and make your own as you go. What are the different service types? These are more or less the different pieces of equipment that we brought over. So when we did the graphics, store graphic elements, this is what was populating. If there's any, and you can see what's in here: ground flex ducts, supply diffusers, suction diffusers, water tube boiler, and so on. If there's any insulation material, that'll populate here. There isn't any in this particular file. Sections are nothing more than what level we're talking about with elevation. And even if you get this wrong, it doesn't matter. It's still going to come in the right spot. But what will matter is all of your all thread will be off. So all your hangers will be incorrect. The hanger lengths will be incorrect. So it's important to get this correct. And then finally, we have what are called fitting ignores. Fitting ignores is a very interesting feature of software, and it's worth mentioning because what it's asking me here is, you see that the column says ignore yes. I can change any of these I want to, from yes to no, right, if I wanted to. The point of this is, what it's saying is, if I run into a problem, software is saying, if I run into a problem mapping these over, there I get to a corner and there's something missing, or somebody dropped Mickey Mouse in the corner, or who knows what, right? There's something that I don't understand. Do you want me to ignore this problem and put in my best guess? And my answer is yes, ignore the problem and put in your best guess. If I say no, it's going to stop at every problem and ask me, the user, to tell it what to put in there. So with yes on, it just knows what to put in there, and I didn't understand how this could be, so I went to the programmer himself and asked him. It's very straightforward. If I have a 14 by 14 supply air duct and another 14 by 14 supply air duct coming towards each other at a 90-degree angle, what probably goes there? I said an elbow, and he goes, you're right, a 90-degree elbow. And it depends if you want square elbow or radius elbow. It depends on what you have set up as priorities in your mapping. It'll pick that one first, but it just knows. And I thought, that's pretty straightforward. It sure saves us a lot of time, doesn't it? So these are some of the cool features. Every little piece of minutia has been thought through in the software, which is why I made such a push for Autodesk to look at this particular package of software. All right? So we'll say OK to that, and Autodesk is doing Autodesk Fabrication CADmep is doing the heavy lifting now. It's doing the other part of this, which is bringing it into CADmep. And so it takes a few seconds and everything will populate. And now you can see that I actually have everything that I had in Revit here in CADmep. So that's the layout in CADmep. This is the layout in Revit. Look pretty similar? Well, that's because it works. So it works very well, actually. And if you want to take a look at it from a different angle, I can show it to you real quick here. Let's change what we look at to. There we go. So we'll zoom up here and take a look at a couple of fittings in here and actually show what the software's actually done with this and what level of detail we're really looking at here. So if I double click on a fitting, let's try to pick something cool. Let's see. Let's just do this one. So just double click on any fitting and you can see here that we have a squared around, and you can see actually what's inside this, what it's going to do with this piece of ductwork, where all the seams are. So you have a Pittsburgh short seam here, you have the different connectors, an S&D connector here, and also all the dimensional values over on the side here. Under the options, you can see that you have the option to deal with this in any way, shape, or form that matches your shop standards, right? So what diameter type is it? Outside, the length break, the girth split, estimated diameter, input length, offset width. I mean, there's just so many different things. There's not really anything you can't customize with these fittings, right? What's your cutback allowance going to be and so on. Under the item tab, we have the item number, what pressure class it is, what insulation spec, what kind of material is in here, whether it's double walled or not is a simple click, and then everything changes, right? And obviously I wouldn't do this fitting by fitting. I would set this up in my spec, but what I'm doing is exposing what the specification has in it. You can change an entire run to these values on the fly if you need to. What service is it and so on. More or less what I want you to see is how many different fields there are here that, so you understand what kind of controllability you have with this, and it's full controllability, right? There's the different service types, right? Oval, pipe work, electrical, I mean, everything that you could possibly move in here. And then last but not least, there's my other information back here on the connectors and the seams and so forth. And if you want to see what it actually will be fabricated like, you move that out, and you can see that. You can see where we have all the tabs on here, all the miters, and even, I'll zoom up for you. You can see down here, I have the V-notches, right? So everything in here is covered. You can set those V-notches how you want. You can control anything and everything so that your shop standards are met. But I can get that for any fitting that's on here. So we'll take a look at one more and then move on. But there you can see another, just a simple elbow with the turning vane symbolized on there. And why don't we have the actual turning vanes shown in? Because we don't need to actually show the turning vanes. What we need to do is account for them in ESTmep, so they are shown on here. So for estimating, they're covered. But you don't actually have to bog the software down with that geometry, right? So it's symbolic in this case. But again, same sort of thing, right? Let's go back here so we can move a little faster. Go to 2D wireframe. And just for, we're doing that time, not too bad. Just for the purpose of today's demo, let's at least spool some of this stuff out so you can see what this looks like. So I've brought a job over from Revit, and what I want to do with it is spool some of this out. So we're going to do that and see if we can do that in a matter of just a couple of minutes. So we can figure some of these things out. So I want to isolate a run of piping. Let's see, we'll pick this one here. Let's do SR, select run. There's the run I want, and we'll isolate that. So we have only that. I don't think you can see it that well, so I'm going to go back to this again. Can everybody see that? I'm hoping you can see that pretty well. It's a little dark on my screen, but I think it should come through okay. But I wanted you to be able to see it there. what we're going to do is take this run of piping and spool this out. Now let's say this particular run isn't going to fit on the truck. So what I need to do is I need to break this down a little bit. So we'll create a couple of spools here. So just using simple AutoCAD command like line, and I'll line it up to the edge here. Just draw a line through it. And we'll use a command in CADmep. It's called Slice Line Tool, SLT. Right? And Slice Line Tool asks me for what cut line I want, and it's just the line I just drew. And when I do, let me zoom up so you can see this. When I select this, I'll get a little dialog box making sure this is what I want to cut. And it is. It's process chilled water supply. And in this case, I have a button code set to put a weld gap in there. We'll say OK. Watch what happens. Let me go and erase this line. And you can see, I'll zoom up real close here, that it's put my weld gap in for me. Right? And now this is one pipe. And there's the other pipe. Right? So with that done, all I have to do now is spool it out. And we'll go to the spool tools for that. And to spool this, it's giving me a spool number 50. I can change the color to whatever I want. I have a color range in here that's controllable. What view do I want when it goes out? What stage is it going to go out as? Is it going to go out as approved, issued from manufacturer, so forth? You can create new stages, whatever it is you want to do in here. What spool reports you're going to use. All the different things you need to control down here. One of the ones I like to show is the same number for identical parts. If I turn this on, it means any parts that are identical will have the same part number associated to them, right? This is a big headache for some people because they don't want that. They want the parts to be the same number, and they can't. They're all individually numbered depending on what software they're using, right? So let's go pick some. So we'll pick the first half we made here. That turns red for me, and we'll pick the next half here. That turns blue, cyan, and then we'll just spool these out. Right. We'll spool these out and say okay. Oh, and by the way, down here, I have the option of fitting these in the Layout tab or not. If I uncheck Create in Layout tab, what it's going to do is it's going to create these in separate PWG files. So you have that controllability. I like to leave them created in the Layout tab because if I do, I have one DWG file with as many tabs as there are spools being created, which also leaves them live links to each other. So the actual spools I'm working with and messing with here are actually still live in the actual model. So if I make any changes in one place, they'll show up in the other. Right? So we'll leave that okay. Oh, something didn't happen right here. I know I opened in the right file. All right. Well, normally what I should be getting up here, and I don't know why I'm not getting it. I did open the correct file here, but regardless, is I have my bill of materials over on the right side. What it's doing right now is it's asking me to number these, right? So I can place the numbers wherever I want to place the numbers, right? Or what I can do if I want to is just hit my escape key and I can cycle through these, which is what I'm doing now. And once I'm done, normally I get my spool report over here on the side, but what I'm getting now is my spool report down here. So unfortunately, you can't see it, it's overlaid, but all the information is developed over here. So something happened with my template file. I did open the correct template file. I don't know why I'm not seeing the correct template file, but regardless, what you see is here's a better view of it anyways. There's the item number that was generated, right? There's the source where it came from, what size is it, what length, what weight, right? These are the different parts and pieces in here. But the point is, what I've just done in a matter of a few minutes is really gone from a Revit file over here to something that I can now send out to the shop floor, okay? And last piece of this I'll show you real quick. Let's go close back up to this. Is if I go and take this, let's go to a top view real quick here. I can go and take this model work here, this line work, and also send this out to estimate. Now I'm going to keep this estimate pretty small, but just type in the command create CAM, and it's going to ask me what objects I want. In this case, I'll just select this to keep it simple. And send it to my desktop. And we'll call this one Microsol again. All right, that sends that out. We'll go over to Fabrication FabMEP. So this is CADmep, right, where we started, and then, or we got the Revit file to. Now we're going to go to ESTmep. And in ESTmep, I want to open up the job I just created. So we'll do Open Job, and under Desktop, I should have down here Microsol, and this is the MADG file. Again, this file format, MADG here, is the file format that contains that common database. So we'll open that, and you can see right away I've got all the parts and pieces from that job immediately at my fingertips. And you can see there's the pipe itself and all the information associated with it. There's the job information. The actual tendered bid is right there, $28,532.75. All the different information on the job exists in here. Everything that we just started off with Revit is now over here. There's my item folders. This is where all the information is coming from. And then here's the database for actual costing and so forth, all the different controllability you have for it. And there's just too much to show in the short period of time we have, but I did want to show you, just expose a little bit of this stuff too, so you can see where all of this is. And when I first took this software on, when I was at Midwest Mechanical Contractors, one of the things that I first noticed about it were there certain things that I thought may not be correct, like where is this, why can't I do that, and so on. And what I found was with every question, the answer was, it's here, it's there, you're just not seeing it. And there were a couple of things they didn't have. But moreover, there was pretty much, I'd say, 90% of what I was asking for was there. It just took some time to learn where it was and what I needed. But simple little things are accounted for. So, for instance, in ESTmep, when you look at the end of a pipe flange and you see a gasket on the end, that gasket is actually half a gasket. Why? Because two half gaskets joined from two pipes makes a single gasket, even though in CADmep it appears as one gasket. So it's an extremely well thought out program, so for estimating and for detailing and for spooling, all the bases have been covered. But what we've done more or less just now is gone in a matter of 3 or 4 minutes, really, if you just did the work and weren't talking or showing this, from Revit all the way through to spooling and to estimating. So all that information exists in